Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. It gives me great pleasure to welcome back Dr. Tim Ball. Dr. Tim Ball is a climatologist who has been teaching and educating people for 40 years in climatology. He has been a professor. He's written thousands of articles. And one of the interesting things about Dr. Tim Ball is that he is interested in the context in which climate happens. He's also studied crop production, the survival of animals in the wild and animals in general. And we have had him on many times, actually. We did a piece with him on the complexity of ocean exploration, examining peer review with best-selling author Gavin Menzies, author of 1421 and 1434. Our first climate show called A True Inquiry into Climate and Weather with Robert Felix and Joe Dalio. And we have done other shows with him. But today I've invited him on because I have a concern, like many of you, about the glaciers melting. And while we've had geologists and climatologists and meteorologists and people from every area of climatology on, I started to read some articles on this and I got very nervous. And I invited Dr. Tim Ball to help set the record for this, how we can understand glacier melting in context. Ladies and gentlemen, welcome Dr. Tim Ball back to It's Rainmaking Time. Good afternoon.
Well, thank you, Kim, and thanks for the opportunity.
The first thing is that many of us who love the Earth and are concerned about our planet keep seeing these articles on the internet and on YouTube. And the thing that concerns me is somehow I came in touch with this site, cc.rsoe.hu/index. I'm going to leave a link up after we get the show to the public. But several of the articles were the following: extreme weather and climate change, leaking Siberian ice prompts methane warning, Austrian glaciers shrink, and melting Arctic ice threatens a quarter of the world's population. Now, when you click into these on this site, and there are different sources like RIA, Novosti, Planet Ski, AP, LA Times, and TVN like Nancy, z.co.nz, what you get are videos of rivers, of streams, of the sun being out, and people talking. For me, it seems all very convincing if I hadn't done a year and a half of due diligence about climate. Now, I'm not saying it makes me a climatologist. I'm not saying I'm fit to be in the conversation at the highest level, but I do have a frame of reference now that I didn't have when I was a global warming advocate or believer, if you will, a year and a half ago. So I would like you to give us the frame of reference for how we evaluate whether what we're being told about the melting Arctic ice or the Australian glaciers shrinking, how do we deal with this? How do we know if it's true or not?
Okay, very, very good questions, and it speaks to what is being exploited here. The first thing is people's fear. That's embodied in the lovely story about Chicken Little, the sky is falling. And of course, then you have on each side the Cassandras, that is the doom and gloom, and then you have the Pollyanna people. And what we're trying to do, and what you're asking about, is how can I come down somewhere sensibly in the middle? Because we know there are events that occurred, catastrophic events, and we also know that there are some very positive things, but there's a tendency to only focus on one side of it. And so the articles that you mention in that website are actually focusing on the doom and gloom, the Cassandra, and so on. And so that fear factor is the first thing that's being exploited. The second thing that's being exploited is people's lack of understanding. And it's not just understanding about the science, but it's also lack of knowledge or understanding about the planet. A Canadian Prime Minister once said Canada's problem is too much geography and not enough history. And I think that applies to the world, but I think it's wrong in that we've got lots of geography and lots of history. The problem is people know very little about either one. And I noticed a story today out of England where students, there's severe criticism of the teaching of geography in their high school curriculum. And and they say, oh, because they're not being taught where different places are in the world. You know, the old standard, you've got to learn a few facts before you can start debating them. So the lack of understanding. And the more obscure but potentially threatening something is, the more they can play on it. Now, the reason I'm making those comments, Kim, is because when I say to people, well, what's wrong with global warming? Because all you hear are the negative sides. In other words, the Cassandras have the platform, and there are a lot of positive things for global warming. And one of perhaps the most nasty attacks I got were about an article I wrote for Canadian consumption about the benefits of warming for Canada. And they didn't want to hear that. Now, it's partly fueled by the Intergovernmental Panel on Climate Change, which we've talked about. They say warming is proven and it's going to continue, and then they look at all the negative impacts of it. They don't look at, well, what are the positive things? So we need less heat energy to heat our homes. We need less fuel because our cars are not idling, and on and on and on. And so you're only hearing one side of the story. But when I ask people what's wrong with warming, they can't think of it. They can't respond to it. And then after a couple of minutes, they come out and say, "Oh well, the sea level is going to rise." And that has become the sort of standard response. Well, why is the sea level going to rise? Oh, well, those glaciers are going to melt. And that's why in Al Gore's movie, he made such a big part of his movie about the melting glaciers and about the sea level rise, and then the computer images of the lowlands, the Calcutta, the delta of the Ganges, Florida being inundated with water, and so on. And those images, of course, are frightening to people.
Very frightening.
Well, of course, you can joke about it. You can say, well, you know, New York's going underwater, and we could see that as urban renewal. But it's, you know, I mean, to step aside from the flippant for a minute, it is frightening to people, and it's partly frightening because, and again, most don't know this, but they intuitively sense this. People tend to live in floodplains, in flat areas, particularly along the ocean's edges. If you take the Ganges Delta, the Nile Delta, the great deltas, or the lowlands of Europe, even in the U.S., the Mississippi area. And it's because those are areas where the soils are fertile, they can produce the food they need, but they're also high-risk areas because of flooding. And when you list the climate disasters of the 20th century, the top 20 of them, 11 of them are droughts, but 5 of them are flooding. So 16 of the 20 are related to this problem of too much water or not enough water. And the flooding one, of course, is a big threat. So that's why it's become such an issue. But of course, it all goes back to the glaciers and the ice, and as I said, people's lack of understanding. Now, just to illustrate the point, and we'll get into the dynamics of ice and glaciers and so on. Sea level has been rising for the last 10,000 years. And it's risen very dramatically because about 15,000 years ago, sea level was 500 feet lower than it is today. And imagine that, looking at the world, just lower the sea levels by 500 feet. And what does that do to the English Channel, the Baltic, and all around the world? You can think of the change to the land-water ratios that would have. So the sea level has risen. The English Channel wasn't there 6,000 years ago. And in fact, the archaeologists find some of their best sites of ancient Britain out under the North Sea, which have been inundated. And so the sea level's been rising. Ironically, the rate of sea level rise has reduced in the last 1,000 years and has reduced even more in the last 200 years. So the rate is decreasing. Now, why has this happened? Well, 20,000 years ago, there were massive ice sheets on the land. North America, almost a third of the continent was covered with an ice sheet, larger in area than the current Antarctic ice sheet. And that ice is formed from water that's come from the oceans. And so when the ice forms on the land, the oceans are lowered. Of course, then conversely, when the ice melts on the land, it goes back into the oceans and the sea levels rise. And that's what's been happening since the end of the last ice age that began approximately 15 to 18,000 years ago. And so, and by the way, in Gore's movie, the claim that he made about how much sea level was going to rise in the future because of global warming, and of course the argument then is the warming will cause an increase of melt of the Greenland and the Antarctic ice sheets. He was even in disagreement, dramatic disagreement, with his fellow Nobel Prize winners, because the Intergovernmental Panel on Climate Change had a dramatically lower rate of increase of sea level compared to his. So that's just further illustration of Gore's sensationalism. But even what the IPCC are doing is based on a single assumption and then projecting forward a single idea that the world is going to warm up.
I want to go back to this melting Arctic ice. One of the sentences that they wrote is, melting Arctic ice affects the climate of the entire planet. Global warming has already driven polar bears to cannibalism and may threaten the lives of a quarter of the world's population by 2100. That's heavy stuff.
Well, and of course it's got all of the good stuff in there. You know, that it's an area that nobody knows anything about, the Arctic. It's got it affecting the whole globe from this one area. And it's got these nice creatures, the polar bears with nice round eyes and white fur. And it's got all of the nasty things about cannibalism. And the problem is none of it is true. I've worked with one of the top experts on polar bears. He lives in Igloolik.
Is that Mitch?
Yes. And I've known him for 30 years, and we've written articles at Mr. Dick, I think it's Dave Dick, we published articles on polar bears in the Hudson Bay area. So I'm very familiar with the whole polar bear story. And of course, one of the things that, we'll get onto the ice thing in a minute, but one of the things about the polar bears, as with all animals on this planet, the populations fluctuate tremendously. And they fluctuate, of course, with what we just finished talking about, the wet and dry cycles. And we did research all across central and northern Canada, and discovered that animal populations fluctuating by as much as 1,000%. That's normal. What's not correct is the scientific view of animal populations. It assumes that they're relatively constant over time, and it assumes that if they crash, they simply are not going to recover. And that's an unreality. I'll just give you one quick little story with this. We were looking at northern Manitoba, and because they claimed the hydro dams, the electric dams, were destroying the Aboriginal population's lifestyle and so on. Well, there was a herd of woodland caribou called the Kaminuriak herd. In 1980, the populations were estimated to be about 7,000 animals. And the government even came in and said, you can't hunt them even though they're your fundamental food supply. You're not going to be able to hunt them. We'll provide you with food, which they did, and they've now got diabetes, but that's another story. Well, 7 years later, so 1980, 1987, 7 years later they went in and there was 155,000 caribou.
Oh, my God.
Right? And right away they're saying, we got the numbers wrong. We counted wrong. We counted too many this time and not enough the first time, and so on. And the reason they said that you couldn't hunt them was because they were down to 7,000. They were widespread. They couldn't possibly recover. And what this was based on, Kim, was in the literature, the academic literature. It said that these caribou the cows calved at 3 years old, and they had one calf per cow. What it turned out was that when the population crashed, and it crashed because there was drought in the region and vegetation disappearing, and then when the rains came back and the vegetation recovered, the animals had a catch-up factor. And what happened was that the cows started calving at 2 years old, and they started having 2 and 3 calves per cow.
Interesting.
Which, of course, then gives you a multiple factor to recover your population. And when you start to look at populations, and by the way, some of the earliest records on ecology, and that word was first used by Charles Elton, who did studies on the relationship between the number of lynx and wild shoe hare, like a rabbit, and he used the fur trade records and showed that the populations of these animals fluctuated tremendously. And then I'm just working on an article now showing that it fluctuates in conjunction with the 11-year sunspot cycle. And so these ideas have been around, but they're still not part of the way people see things. They think that, if a population crashes, that's the end of it, but it's not the case. And both plants and animals have these catch-up factors. So when they talk about the polar bears, it's exactly the same thing. And the idea about cannibalism, of course, it's just simply a non-correct story. There was another story put out that they were wasting away, and the reason that they were suffering from hunger was because the population had exploded. There were too many animals for the region, and then when the drought came in and the food supply disappeared, well, of course, nature's going to kill some of them off. That's the way it works. And so they take little bits of these stories and, of course, sensationalize them into the stories that you're reading.
Can I give you one more before we start to go into the whole shrinking glaciers thing? So the second article says Austrian glaciers shrink. Incidentally, this was done on my birthday this year, May 8th, 2010, source Planet Ski. It says 91% of them reduced in size last year. Some of them by as much as 46 meters, according to the latest figures. The Austrian Alps Society has released the statistics and makes worrying reading for environmentalists and those concerned about the mountain landscape. The sharpest decline was some of the glaciers in the Tyrol on the mountains of I can't even pronounce this. Oh, my
God.
God.
In Austria. It's
Niger-Jofferner.
That's where the yodeling comes from.
Yeah, Niger-Jofferner, Kessel-Wand-Ferner, and Mosel-Van-Ferner. God help me with my accent. All right, the society has been studying the glaciers and their size for over 100 years. One glacier did actually grow last year, but only by a few centimeters. The melting is put down to rising summer temperatures. So when you read stuff like this, and these pieces are coming in from all over the world, it's very difficult to receive this and stand in the knowledge that we don't know what we're getting for information. We're getting bits and pieces of things. So can you lay out whatever you feel to be the truth about the glaciers and how they're analyzed, whether they're shrinking or growing? Bob Felix says they're growing. Other professionals say they're growing. And yet we get a lot of news saying everything is shrinking.
Okay. Just one quick comment was that one of the false pieces of information that were deliberately put in to the Intergovernmental Panel on Climate Change report was that the Himalayan glaciers were melting, and they'd be all gone within so many years. And it turned out that was deliberately created and put into the IPCC reports. And they had to come out and apologize and say it was wrong. And so here you've got the so-called UN official agency deliberately presenting incorrect information about mountain glaciers. But just one interesting little comment that I'll start out with. I'll pose you a question. Interesting to go back and look at Hannibal. And Hannibal, of course, was the leader of the Roman portion of the empire in North Africa. And, of course, he was from Carthage, which is in North Africa, and he came over to attack Rome. And he took elephants through the Alps in Europe, and he took them through regions that today have glaciers in them. And so if you go back to the Roman era, 2,000 years ago, the world was warmer than it is today. And so the glaciers grow and retreat all of the time, and you can show that back through history. And of course, one of the things I want to start off with, Kim, is pointing out that, well, let's look at at ice. First of all, ice forms in two ways. It forms either by water freezing and becoming ice, which the one people are familiar with, but the glaciers form the ice in them is formed in a different way.
How?
It's formed by snow falling, and of course snow is simply ice crystals that have collected together, and there's another part of the mythology of science where they say no two snowflakes are alike. Everybody hears that comment. My comment is, prove it. I mean, how can you look at even a fraction of the snowflakes in one snowstorm? You mean, go to Ohio today and say, look, all those snowflakes are different. Oh, yeah, sure. And so it's a function of the crystallization. But anyway, what happens is that snow falls, and if the snow then can survive through the summer melt, and of course that's part of the comment in that one article, they say, well, summer temperatures are warmer. Then if that snow survives through the summer, then next winter you get another layer of snow, and then gradually the snow layers accumulate. And what happens is that as they accumulate, the snow in them changes. It's a process called nivation, Nivation, and it's another term of things that are going on is melding, MELD. Now, skiers know that you can get different types of snow. You can get the nice soft powdery snow, the freshly fallen snow, but when you get old snow, it's very granular. And that's because the snowflakes are starting to meld together. They're not melting together, they're actually melding together and forming into these granular lumps. Now, and of course, then there's air between those granular lumps, and that's valuable, by the way, for creatures living under the snow. I worked with a guy who did a whole lot of research on snow and survival of animals under the snow. In fact, had a cabin out in the northern Manitoba. They spend the winters out there. But that provides air and movement of air, but it also provides an insulation under the snow for animals that live under the snow. But anyway, gradually, as the snow layers build up, then they push together the heat and the weight of the overlying layers gradually makes it form into ice. Okay, but you need quite a depth of this snow for that to form into solid ice. So if you go to a glacier, you get about the upper 150 meters of it have these quite distinct snow layers that are becoming ice layers. And then they form a brittle ice, an ice that will crack. But below 150 feet, the ice is now under such heat and pressure that it becomes plastic. So, and then when it's plastic, of course, it will flow just like water. The ice will flow. It's much slower, obviously, but it flows just like water will flow. And so in a glacier, as you go down through the glacier, you've got the brittle layer in the top 150 feet. And then below that, you've got the plastic layer, which is constantly moving down slope because it's plastic and it will flow. Now, when that plastic layer goes over a rock or a cliff, it will flow and bend. But the brittle layer can't bend, so it cracks. And then you get the crevasses that are formed, the cracks in the ice. But the crevasses only go down a certain depth because then as you get down to the bottom, you're down to the plastic layer, which is not cracking. And I used to tease the students, said, look, if you're going to fall into a crevasse, don't worry, you're only going to go down about 150 feet, and you'll be able to climb your way back out again. But anything that falls into those crevasses gets absorbed into the glacier, into the plastic part of the glacier, and then that will move through the ice out to the snout, which is the front of the glacier. And there's one quite famous story of a soldier, a Swiss soldier 400 years ago, crossing the ice, fell in a crevasse, and emerged at the snout of the glacier back in the 20th century. And of course, again, I would tease the students, say, look, if you fall in the crevasse, just hold your breath, and sooner or later you'll come out at the front.
Oh, my God. That's wild.
Yeah.
All right, now what does this mean to us?
Well, what it means is that the snout or the front of the glacier doesn't actually melt in a sense. Well, let me back up a bit. The front of the glacier seems to move forward or move back. But within the glacier, the plastic ice is constantly flowing to the snout of the glacier. Okay? So even though the front of the glacier, the snout, appears to be moving back up the valley, the ice is still being delivered to the front of it. That's why when you look at any mountain glacier or the Antarctic or Greenland glaciers, at the snout, it's very dirty. There's all sorts of debris, and in fact, there's an article out just recently claiming that this increased debris is increasing the rate of melt at the snout of the glacier because it attracts the heat more than the white snow or ice that reflects the sunlight. And so I used to describe it this way to the students, still do to everybody else, that a glacier doesn't retreat, it advances to the rear.
That's strange, isn't it?
Yeah. Okay, so what you've got going on then is that glaciers form either in high ground, and you get them, by the way, even at the equator. You get glaciers in the Andes Mountains above a certain level. So there you've got altitude is determining the front line of the glaciers and the snow line, by the way, or in terms of latitude. And I love the idea that if you just change the first two letters of altitude and latitude, it's the same word. And they're directly connected because as you go up the side of a mountain, you go through the forested area, and then you get to the tundra, or you get to the tree line, and then the tundra, which is Russian for treeless zone, and then you get into the permanent snow line. All right, and this is true as you go north or towards the South Pole. So as you go towards the poles, you go through exactly the same changes in climate and vegetation and glaciation, the same thing. And so these glaciers then take two forms. They either are formed in mountains, and they're called alpine glaciers, and that's the ones they're talking about in the Tyrol that you read out, or they are continental glaciers. That is, that they sit over a complete landmass, and the two most famous ones today are, of course, of Greenland and Antarctica. But they both form in the same way. They form by an accumulation of snow that gradually turns to ice, and then once it reaches the plastic level, it starts to flow. So, for example, in Antarctica, they keep talking about, new icebergs breaking off. This is a sign of warming. No, it isn't. In fact, it's a sign that the glacier is growing, because as the snow falls, the weight of the glacier pushes down, which squeezes out the ice around the edges out into the oceans, where it breaks off and forms icebergs.
So there's a science to glaciation.
Oh, it's huge. It's huge. And in fact, the history of the Earth is that we're under glaciation far more than we're under warm periods like we are now. We should be grateful to be alive during an interglacial. Because I got to tell you, you don't want to be around when there's a glacier. You imagine North America with 1/3 of it covered with a massive ice sheet?
No, I did an interview with Don Easterbrook a few weeks ago, and he was very concerned that we're in a cooling cycle based on the sunspot activity and what's happening around the world and the food supply. Very concerned.
Oh, absolutely, and I agree with him. Now, I'm concerned about it, but I joke about it. I say, well, we knew where the glaciers form. They'll form in the same places this time, and we know which way they move, so we know which way to run to get away from them.
So where do we go?
Well, you head south, because Florida will be bigger, because the water will have come out of the oceans and the sea level will have dropped.
So we head south, not north.
Yes, and of course
here we come, Texas. No,
but it's of course one of the things that happens as the glaciers expand in the polar regions. Then the one climate zone that disappears are the desert zones, which are within 15 to 30 degrees of the equator. And the Sahara, of course, is the classic example of it. During the last ice age, 20,000 years ago, the Sahara Desert became grassland and lightly wooded area, what they call now in Africa savanna. And of course, one of the interesting things about that was that that allowed people to get out of Africa across the Sahara Desert, which prior to that was really a huge barrier to movement. But and by the way, those wetter regions in the desert areas, those are called pluvials, from the Latin word for rain. They are now in an interpluvial, that is, they're in an arid time period. In the polar regions, we're in an interglacial, and 20,000 years ago, which even in human terms is yesterday, we were in a glacial. And so what I've described for you then are the three different forms of ice. One is the sea ice, that is water freezing to form the sea ice. The second is the glaciers forming into brittle ice, the upper layer of it, and then the plastic layer beneath it, which causes the glacier to flow. Now, to go back to the Arctic ice, which was part of the original question, Arctic ice is already in the ocean. The ice is formed by water from the ocean freezing. And by the way, it freezes at a different temperature than fresh water because of the salt in it. Now, people know about that because you got ice on your sidewalk, you throw salt on it, causes the ice to melt. So that fresh water starts to freeze at about 2 degrees Celsius, and sea ice doesn't start to freeze till about minus 4 degrees Celsius. There's a full 6 degrees Celsius difference between the freezing of sea ice. But as the seawater freezes into sea ice, it freezes out as fresh ice. So if you were to take a chunk of frozen seawater, it would be fresh water. Now that, of course, is making it makes it tempting for people towing ice and getting fresh water supplies and so on. But a lot of people say, "Oh no, I've tasted the ice by the ocean and it tastes salty." Well, that's because of the salt spray and the salt that's in the air around the oceans. And but sea ice, and that one, by the way, was a very interesting question when the two astronomers, Wales and Diamond, were sent by the Royal Society to Churchill on Hudson Bay. One of the things they were asked to do was to determine if sea ice was fresh water or salt water. And it just simply wasn't known at that time.
I think most of us would assume it would be salt water. Of
course. But you see, one of the things, you remember the term freeze-dried coffee?
Yes. Terrible.
Well, that what they're telling you is the process by which it's another form of distillation. Like distillation is when you boil the water and you get water evaporating off of it. If you condense that water, then it's much purer water. That's what distilled water is, right? It leaves all the junk and the minerals behind. Well, the same thing is when water freezes, there's a distillation process going on. The ice that's formed out of that frozen water leaves behind the impurities and the salt.
So can I bring us back for just a moment?
Yeah.
Okay. I want you to be able to finish what you're saying, but I want to bring us back. So How do we, the public, non-climatologists, how will we ever know if the glaciers are melting or whether they're just growing and breaking off? What is distinguishing our ability to know that for a fact? Obviously, we can't rely on the press for this.
No.
We can't rely on the traditional press for this. It seems to be around the world because I'm looking at the RSOE, the Emergency and Disaster Information Services for Budapest, Hungary, when I'm talking to you about these articles, which also have videos, by the way.
Yeah.
So what do we do to actually know the distinction? There's got to be some precursors to the glaciers are growing and then building and breaking off versus they're melting.
Yeah, of course, the first thing that you need to know is that you need to look at the source of the information. If it's from the media, it's almost invariably going to be sensationalist because journalists learn very quickly that if it isn't sensational, their editor isn't going to publish it. And of course, trying to fill a 24-hour news cycle demands increasingly bizarre stories.
But let me tell you how pervasive it is. I'm looking at a emergency and disaster information service Budapest, Hungary website with different sources, obviously, of news, you know, like the AP for LA Times and Planet Ski and RIA Novosti, tvnz.co.New Zealand. In other words, they gather data from different places, so it's very hard for us not to be ingesting this as the reality going on. Can you see how pervasive it is?
Oh, sure. And that's the consensus argument. Look, all these other sites are saying this, so it must be true. But what you find is that most of it's originated from a single story that's been planted by somebody who has an agenda. I mean, and one of the things that I've watched occur over the last 35 years is the media monitoring certain journals like Nature or Science, looking for articles that have what could be turned into a sensational argument. You can say, well, it's in this scientific journal. Most of the time, it's a scientist speculating. And then most of the time, and this is something I've grappled with for a long time, Kim, is that when you read the article, it has all of the conditional words in it. It says, it could or it may, and that's something people need to look at. How often are those conditional words in there? How often is it, well, this may happen or this could happen, not that this is happening. And then what happens is, so those are in the article, and you'll find a lot more of them in the original piece. And by the way, if you go and read the Intergovernmental Panel on Climate Change, the science report, not the summary for policymakers, which of course they've made sensational because they're trying to influence policy, but you go and read what the scientists are actually saying, you'll be saying, what's the worry? These people are admitting they know virtually nothing. And one of the things that I've been working on is pulling out these pieces from the science report and saying, well, look, this is what they actually said, and here's how it arrived. And it's not without reason that the summary for policymakers, which is released to the media a few months ahead of the science report, that was set up deliberately so that the more sensationalist aspects of it would have an influence upon people and the policymakers because, of course, they're looking for more funding. And one of the things, that's the first thing. The second thing is when you read the headline, and you've been around in media enough to know that the headlines have to be sensational. They have to be in the active voice. They have to grab your attention. That's what they're for.
Well, they're definitely very, very fearful. There is a phenomenon I do want to talk to you about that's associated with this, and I don't want to detract from the focus of the segment, but I do want to say this to you. It is obvious to many people around the world that there is and appears to be extreme weather going on in different countries of the world in many, many different ways. And I know now that extreme weather has been around forever, all over the world for millions of years. But we happen to all be alive at a time where we are observing extreme weather happening in different places. And the thing is, even if there is extreme weather happening, flooding or a lot of rain in one place, a volcano erupting in Iceland and earthquakes happening here and there, it seems as if all of this is being placed inside the conversation of climate change, inside global warming as the reason. I think I read something a couple of weeks ago. I can't remember who said it, but somebody said it's cooling around the world because of global warming.
Yep.
It was crazy. It's like grasping at straws.
Yep.
The thing is, what do you say about the extreme weather issue on its own?
Well, I love the comment that I can't attribute it to anybody, but somebody said that the unusual weather is more unusual than usual.
It'd be good to find out who said that. That's funny.
Yeah, it would. But there's a couple of things about it, Kim. One is, of course, that I've already mentioned, the 24-hour sensational news cycle. The other thing is that things can go on, and we're not aware of them. And it's much like if you're introduced to somebody, it seems like every time you turn around after that, there they are. They were always there. They were just not part of your...
They weren't on the radar.
Yeah. Okay, and so now what's happening, of course, is because the climate change issue has come onto the world's radar, because they want to use it to say, oh, we're causing all these problems, we got to stop this, and we got to control you here, we got to do that. People are saying now, the media are reporting every single little storm. And if you look at Fox are doing it, ABC are doing it, they're all doing it. They don't have weather reports anymore. They have extreme weather. Well, it's always a hurricane. Oh, this is extreme. No, hurricanes have gone on for centuries.
Can I read you this one headline? Extreme weather and climate change. Victorian towns are also going through less dramatic but still serious flooding, and there are snowstorms in the U.S. and Europe, heat waves in Russia, floods in Pakistan, China, and Brazil. What does this all mean? Nobel Peace Prize recipient scientist David Karoly is the lead author on the International Panel for Climate Change and says this extreme weather is in line with scientific predictions. Mark Sainsbury spoke with David Karoly. This is what I'm talking about.
Yeah, but of course, you see, Karoly is wrong. He's not a climate expert. He doesn't know the history of climate. I mean, if I tell you that Charles II ordered people to take a day off work and that they had to go to church and they had to pray for cold winters. Why? Because the winters were so mild that they were afraid that the plague would come and hit them. I mean, this is absolute nonsense.
Now, why did they give him the Nobel Prize? Does everybody who talks about climate change get a Nobel Prize? I don't get it.
Of course, the IPCC got a Nobel Prize. Al Gore got a Nobel Prize. And he got it a week after a British court had ruled that there were 9 major scientific errors in his movie and that it was a political document. But the Nobel Prize Committee didn't go and learn that. They didn't go to the Internet and find out what was wrong with Gore's movie. It's all political. The whole thing is political, particularly the Peace Prize. And by the way, why should the people at the IPCC, who are mostly government employees, and I paid their wages, and they get the money from the Nobel Peace Prize? I mean, this is ridiculous.
I wanted to just clarify both to you and to the audience the pervasiveness of how propaganda gets built.
Oh, yes.
This is it. This is an example of it.
Yep.
And very believable. And so the unsuspecting person who loves their planet, who loves animals, who loves trees and the forest and nature and mountains and lakes and the ocean, etc., can get sucked into this.
Yeah, exactly. And by the way, just let me quickly explain why the weather seems to be more severe. It's not because of warming, it's because of cooling. What's been happening is that the polar regions have been cooling down. The southern hemisphere for at least have been setting record cold temperatures for at least 4 years. It's now having it's had an effect in the northern hemisphere for 2 to 2.5 years. And what happens is, if you think about the Earth and imagine in a three-dimensional Earth, and then the atmosphere is basically two air masses. There's domes of cold air over the polar regions, just like a cap of cold air, and then there in between is the warmer tropical air. And as the sun changes the energy coming into the Earth, those polar domes either expand as it gets cooler or they shrink as it gets warmer. That happens on a seasonal basis. And so where the two meet, where the cold and warm air meet, is called the polar front. It's the most dynamic part of the Earth's atmosphere. It's along that front that you get the severe storms that you're having tracking through the U.S. right now. In the old days, they called them blizzards. And if you want to read about some incredible blizzards compared to what they're getting now, go and read David Ludlam's wonderful books on American weather history and so on. But what happens is that the temperature contrast between that cold air and the warm air is what causes the severe weather. It's along that boundary that the tornadoes occur and develop, and these severe storms, and they call them cyclones, cyclonic weather. And just to give you an idea, Kim, of how dramatic the temperature difference across that polar front can be, the most rapid change in temperature on record was at Spearfish, South Dakota in 1943, where the temperature dropped 27 degrees Celsius in 2 minutes.
Oh, my God.
Okay, now we know that because they had those big old drum thermometers with the ink marker going along on it as the drum rotated. And during that day, the temperature rose and dropped 20 degrees Celsius 3 times because they were in the warm air at plus 20. The cold air came in and it dropped to minus 7. Now, people across the northern U.S. are familiar with this. These dramatic changes in temperature as this cold air comes in. And, of course, Americans talk about, the cold air advancing from Canada. What they didn't realize was that this was part of the NAFTA agreement, that we send you cold air and you anyway. I'm sorry, I shouldn't be so flippant.
Actually, no. I think we should do a separate piece on the whole NAFTA agreement.
Yeah, absolutely. Now, in this polar front, and by the way, above the surface, related to it, is a very rapid flowing river of air, which is technically called the circumpolar vortex, but most people know as the jet stream. Okay, and as that
I was just going to ask you about the jet stream. Yeah. I love it. Go on.
Okay, well, as the jet stream flows from west to east, and it does it in both hemispheres, it meanders back and forth. It's something called sinuosity. And that's not fully understood by scientists, the concept of sinuosity. But it wanders back and forth, and of course it creates waves in the polar front, and those waves are called Rossby waves. They were discovered by an American meteorologist, Carl Rossby, back in 1946, if you can imagine. And those waves move from west to east, and as they move, you go through the different patterns of weather. So you could be in the warm sector or wave, and you've got warm temperatures, then the temperature changes, the weather changes, you get into the cold air, and generally those patterns of weather last for 4 to 6 weeks. Now that's significant because just the other day you had Puxatawny Phil, the weather forecaster, right, the groundhog. That's based upon people's awareness that the weather patterns shift on approximately 5 to 6 week cycle. Okay, so and it's based upon these waves in the jet stream that migrate from west to east. But the waves are not the same amplitude in a north-south pattern all the time. They get much higher or deeper. So you get warm air pushing well north, and you get cold air pushing very far south. That occurs as the Earth is cooling down, which is precisely what's been going on for the last 8 to 10 years. So as that polar front is pushing further and further south, you get these extremes of weather that are warm in one area and cold in another. And you look at what makes Arizona last night, whether it was minus 3 Celsius or something. You see this cold air pushing well south. That's been going on in the southern hemisphere. They've had frost as far as southern Brazil over the last several winters. And so, of course, the global warming advocates are saying, oh, no, this is because of warming. In fact, they're 100% wrong. It's because of cooling. But it's because they don't understand these general mechanisms that create the climatic patterns that go on all the time.
Is it true that our jet stream is changing?
It changes all the time. It increases in speed. It varies in speed around the globe. And as I said, this pattern of it changes.
Not to get deeper in, although we may be deeper in, but is it influenced by our magnetic field?
Yes. Yes, and of course, one of the things people talk about is how the moon comes up and we get, full moons, we get different weather patterns.
Right.
The moon influences our magnetic field. And that's the relationship.
Does the sun?
And people that are making accurate forecasts, not only on a 4 to 5 day basis, but on a 3 to 4 month basis, is a guy by the name of Piers Corbin, an Englishman. And he's got a
AccuWeather, right?
Yeah, Weather Action. And he's
Weather Action.
Yeah, he's been making very accurate forecasts, and what he's doing is he's using changes in the solar output which cause changes in the magnetic field of the Earth, and as the basis of his forecasts.
I cannot imagine anybody not considering the impact of the sun and the sun on the magnetic field here in terms of looking at climate. I can't even imagine that would be omitted from the equation of looking at climate.
Okay, well, let's loop that back, Kim, because you see, the reason that the weather has become such a big issue is because of the Intergovernmental Panel on Climate Change, okay? And their reports about, we're warming and it's definitely going to keep warming. The fact they've been wrong with every forecast they made is forgotten in the hysteria. But what people don't realize is that their definition of climate change, given to them by the United Nations, by the United Nations Federal or Commission on Climate Change, was they only look at climate changes caused by humans. They don't look at natural causes of climate change.
You mean cyclical?
Oh, any of them. They don't look at the sun. They don't look at the cycles of the ocean. They don't look at. They don't even look at water vapor.
I thought it was
the
fascinating.
Most important greenhouse gas.
I thought it was fascinating that most of the greenhouse gases are water vapor. What's the percentage? Do you know?
95% by volume.
Unbelievable. Unbelievable.
Yes, so what they've done is they've defined their role is to look at climate change as the human causes of climate change, and of course what I keep pointing out to people is you can't possibly determine what portion of climate change is human if you don't know how it changes naturally. But that's what they're doing. And by the way, just back to the Arctic ice, can we flip back to that for a second, just to illustrate the point here?
Yes, please.
Every single winter, the Arctic freezes over, and surrounding oceans, Hudson Bay, for example, and out into the Bering Straits, and approximately 15 million square kilometers of ice forms every winter. But every summer, about 10 million square kilometers of that ice melts. So about two-thirds melts every single summer. Now, 10 million square kilometers of ice is an area equal to the continental U.S. Most people don't even know that.
I don't. I'm not sure the listeners know that either.
No. So you've got 10 million square kilometers of ice melting every single summer. But here's the most remarkable thing. That 10 million square kilometers melts in about 140 days. That means it's melting at the rate of 66,000 square kilometers of ice a day.
Wow.
And that is equal to half the size of the state of Illinois every single day. Okay, and now let's do that. Let's play the sensational game, because a couple of years ago they came out and they. Okay, because a couple of years.
You're making me laugh. Go ahead. Let's play the sensational game.
Yeah, a couple of years ago they came out and said, "Oh, more ice melted this summer than last year, an area the size of Texas." Okay, why did they use Texas? Oh, it's big in people's minds. That's a huge area. But in fact, Texas is an area, as a percentage of the 10 million square kilometers, is only about 4%. So that 4%, of course, is within the natural fluctuation of the amount of ice from year to year that melts. So it's actually well within normal variability, but because of the way they presented the story and because they know people don't know that 10 million square kilometers melts every single summer, that they can get away with this stuff. And of course, then they say the polar bears, they're drowning, and Gore had that movie. And the woman that took that picture, by the way, of the polar bears up on that chunk of ice, she came out and said, look, we were on a cruise up there, and we watched the polar bears. They swam over and got up on the ice to get a better view of us. And another interesting part of this, just to illustrate Kim, lack of understanding, and I mentioned working with the polar bear people. Polar bears only evolved from Alaskan brown bears about 100,000 years ago, which is relatively recent. They adapted to a white coat in order to hide from their prey, which is mostly seal. They are superb swimmers. I have seen them 80, 90 miles offshore swimming away in the open ocean. The reason that they're good swimmers is because of the way that their fur is structured. The polar bear needs two types of furs. It needs a short fur, which is very dense, And to illustrate how dense, when I was working at Churchill, there was a scientist there wanted to count the number of polar bears. And he said, look, I'll just go up in an airplane with an infrared camera, and I'll take pictures of them, and wherever they are, the heat will show, and I'll count the heat spots, and that'll tell me how many polar bears there are. He found out that they took an infrared picture of the polar bear, and it didn't show up, because the polar bear retains so much of its body heat, none was escaping through that fur.
Fascinating.
That's remarkable, okay? And of course, the polar bear literally controls its body temperature through its anus. Now,
that's definitely a TMI type of content.
Yes.
I did a piece with Mitch Taylor, but he didn't mention that. That was interesting.
Well, I guess Mitch didn't want to be as indelicate as I am in your program. I feel that I'm more familiar with you than Mitch.
Let me let you finish, and then I wanted to ask you about methane. And I want to talk to you about permafrost, but please go ahead.
Yeah, okay. Now, the other fur that the polar bear has is the long fur, which is hollow. And, of course, the polar bear needs to get sunlight into it. It's got two things going against it. One, it's got this very dense fur, but it's also white. And, of course, white means you reflect a lot of the sunlight. The polar bear, for its climate, should be black. But if it was black, it wouldn't be able to sneak up on its prey. And, of course, its prey is white because it's trying to hide into the snow background. So this fur that the polar bear has is hollow. The sunlight hits it, is transmitted down inside the fur into the body to raise the body temperature. Now, if you've got fur that is hollow and long like that, it means that you can float. And if you next time you look at polar bear swimming, you'll see how all this long fur is up all around it, floating on the top of the water. And the polar bear just simply paddles away with its great big paws, which are wide and flat so that it's like a snowshoe, but that works wonderfully well as a paddle in the water.
Have you ever met one?
Oh, yes.
How close were you?
Oh, within about 20 feet.
And how was it for you?
Frightening. Frightening.
Were you in a boat, or where were you?
We were on searches out of Churchill, and we went out into the town of Churchill. And of course, what they do is they wait along the shore of the Hudson Bay, waiting for the ice to form, and you have to be very careful because the boulders and so on. You can't tell what's a polar bear and what's a boulder.
I think at some point you would find out.
Yeah, oh yeah, you would. You get surprised. Well, and of course they have polar bear patrols. I mean, for the kids going to school and so on. And we just happened to surprise this one, and fortunately he was more surprised than we were.
Thank God.
Took off the other way.
Now, this was during your search and rescue days.
Search and rescue time, yeah.
Tell us briefly about your search and rescue. What did you do?
I was a navigator and electronics officer and flying with the Canadian Air Force, and we were based in Winnipeg, but all of our search area was into the prairies and then the Yukon Northwest Territories right to the North Pole. But most of our searches were in the wintertime in the Arctic. And of course, one of the things that every nation has to do as part of their UN agreement is provide search and rescue. And so I was on and this was long before GPS was available. And one of the things that people don't realize is you reach a certain point in Canada where there's a line on the map which says your compass is unreliable beyond this point. And so people were constantly getting lost. The other thing is, in the wintertime, once you get north of the tree line, the lakes are frozen, the snow covers everything, you can't even identify lakes, so it's very easy to get lost. And so I was involved in a lot of the major searches in the early days in the Arctic and the Yukon, and it was one of the things that got me really excited about this planet and how incredible it is. For example, Baffin Island and the fjords there, they make Norway look like a flatland. It's just an unbelievable experience. Only two things I regret. One is I didn't take enough photographs, and the other is I didn't buy enough Eskimo carvings before they got too expensive. But I did buy some. And by the way, I got to know the Inuit people, or as Canada calls them, incredible people. Absolutely incredible people.
Why do most...
How they survive in that environment is just amazing.
Well, how do they survive?
Well, they do what we've got to do. You don't fight nature. You go with the flow. You go with what nature will allow you to do, and you know that, as most people know, that nature can kill you. She's a pretty harsh mistress, and so their technology and adaptability of things. I had a friend who was a radio officer in an Eskimo village, as it was then, and he had a radio, and one of them came in one day, was looking at it, took the radio apart and put it back together again. He'd never seen a radio in his life. Their technical skills are absolutely incredible. And, Ron said to him, well, how could you do that? And he said, well, he said, if we needed it, we could build a radio, but we don't have a need for it.
My dad was a radio officer in the war when he was stationed in Paris.
Yeah.
Long time back.
Yeah. Well, as I said, the Inuit people, they could take anything and turn it into something useful. I mean, look at the kayak as the most incredible vehicle, ship that you could imagine, and sailing in incredibly dangerous waters. And by the way, when we talk about past weather, and in the period from about 1690 to 1730, about a 40-year span, there are at least 6 reports of Eskimos in kayaks showing up on the coast of Scotland.
Interesting. Can I bring you back to something about Greenland?
Yes, okay. Yeah.
Is the Greenland ice sheet breaking or melting or neither? What's the bottom line on Greenland? Because a lot of the imagery we see...
Yeah, the answer is all of the above. Greenland, of course, is it's left over from the last ice age. And one of the things, first of all, the bottom of the ice is below sea level. If the Greenland ice cap was to melt completely, you'd simply be left with a string of islands around the outside, because the weight of the ice pushes the land down. And the same is true of Antarctica. You drill down in the Antarctic ice, by the time you get to the bottom, you're several thousand feet below sea level. And but the Greenland ice cap, of course, when they get to a certain size, these ice caps create their own climate and can maintain themselves. And one of the things that anybody that's been around the edges of these very large glaciers, Antarctica or Greenland, the winds are very, very strong. I mean, there's a place, Cape Denison in the Antarctic, where the average wind speed is about 55 miles an hour.
Wow.
And the reason for that is it's the cold air draining off of the glacier. And, of course, it drains down off the dome of the glacier out to the oceans all around. And it's called katabatic flow. It's a lovely word. People that talk to anybody that's flown into Thule, Greenland, for example, the American military base there, you can experience incredibly strong winds. And quite often they have to close the airport there because of it. And so the glacier itself creates its own climate by this drainage. Generally, snowfalls over the glacier are quite low because they are high pressure, because of the cold air, high pressure areas. And both the Antarctic and the Arctic, the South Pole and North Pole, are what we call, in climate terms, cold deserts. That is that the amount of precipitation annually is extremely low. The North Pole, for example, is about 2 millimeters a year, which is barely fractions of an inch of precipitation. But it looks like there's lots because the snow falls and doesn't melt. And but the Greenland ice cap then has its own climate pattern. It is, of course, as with all glaciers, it's actually, because it's in the line of the Gulf Stream and the warm air flowing in, it gets more snowfall than our Antarctica or the North Pole, but still relatively low. But you've got snowfall falling, and of course, the amount of snow falling determines the dynamics of the glacier as much, and in most times more, than the temperature. So the interior of Greenland is getting snowfall. That's accumulating, pushing down, and as it pushes down, the plastic ice flows out to around the edges of the glacier, and where that floats out into the oceans, particularly along fjords, that's where you get the icebergs calving off. The same thing happens around Antarctica. The ice pushes out into the ocean. Ice floats because it's a lower specific gravity than the water. And of course, with the tides and the waves and the action, they break off. And of course, the one that everybody knows about is the iceberg that sunk the Titanic. And so what's happening is you can take any part of Greenland and you can show one area where the ice is melting more rapidly than another because there are the regional climates in different parts of it, different things are going on. It's a very large body of ice. Right now, all the evidence is that the Greenland ice cap is getting larger, and the increase of glaciers off of it is a measure of that. They're not a measure of melting, they're a measure of a growing ice cap. And we had the same thing up on Baffin Island about 3 or 4 years ago when a large shelf of ice broke off, and everybody said, oh, this is warming. No, it wasn't. It was because increased snowfall on Baffin Island had caused the mass of ice to increase.
Can you imagine how many people don't know what to accept?
Oh, I know.
And not even how to think about this?
Yeah. Kim, I taught a course called, it was actually a science credit for art students, and I just called it The Way the Earth Works. And I said, as citizens of Earth, you need to know how your planet functions, because if you don't, you can be exploited. People can come along and tell you this is going on and that's going on, and you won't know. It's the same way that I argued in any curriculum. There should be at least an hour on how to roof a house, because everybody's going to have to roof a house sooner or later. Now, they're not going to have to do it, but if they don't know how it's done, then some unscrupulous tradesman can come along and take advantage of them. And that's what our education, where it's failing us so badly, is it's not teaching people to be students of Earth and citizens of Earth. And this is made worse, by the way, Kim, because most students, 80%, are not scientists. In fact, are afraid of science and almost proud of that. And you see that in law schools. Almost all the lawyers are art students, not science students, yet they're more and more every day confronted with scientific issues about solar collectors and pollution and all these other things. They're not prepared to deal with it.
I agree with you. And I wanted to talk a little bit about this other piece here that came from the AP as the source that was reported in this online emergency and disaster information services for Budapest, Hungary. And it says, leaking Siberian ice prompts methane warning. As Siberia's thawing permafrost leaks methane, some scientists are warning of another emerging climate threat. I don't want to take us off track in terms of what the focus was, but what are they talking about?
No, it doesn't take us off track at all. Now, I'll take you off track initially as a lead into this. Methane became an issue because it's one of the greenhouse gases. Okay.
What percentage of it is in the greenhouse gas, is it?
About 0.009%.
Okay.
It's fractional. But it became an issue because it served two purposes. It served a purpose as a greenhouse gas, but it also served a purpose for the animal rights people and the anti-beef brigade. Okay, and Jeremy Rifkin, and I hate to give him any credit or mention his name even, but he wrote a book called After Beef, and he blamed the cow for all of the problems of Western civilization. Incredible thing.
Wow.
And of course they were saying that the cows are producing methane and that's causing global warming. And a lot of the farmers, I worked as a technical advisor for the Canadian Cattlemen's Association, and they were genuinely concerned. They said, is this a real problem? Do we need to worry about it? What's going on here? And then Rifkin came out with his book. Now, you notice you haven't heard much about the methane lately until this kind of article.
This came out November 23rd, 2010.
Yeah, well, they're doing that because CO2 is starting to lose its luster. People are starting to realize it's not the cause, so that you flip back to the methane one. Well, I say, well, if that doesn't work, we'll go back to this scare. And so the methane issue has come back into the news because the CO2 arguments and the email leaks and all the rest of it. Plus, of course, the reason they changed from global warming to climate change was because CO2 is going up and the global temperatures are going down. And so they've got a problem there. But the methane issue, as I said, that's where it started originally. But of course, then people saw it as more in terms of oh, it's a greenhouse gas and therefore we've got to reduce it. New Zealand even planned to introduce, and they're still working on it, a tax on animals that produce methane. And of course, were you going to include humans in that? I guess I don't know.
I would imagine we're made of carbon dioxide too.
Yeah.
Can you explain something else to us? Create a context for us. Permafrost. I get a lot of emails saying there's permafrost thawing all over the world.
Of course, there is.
I mean, it's NBC, CBS.
Yeah, permafrost, and it's a fascinating stuff. It means permanently frozen ground, but the ground isn't frozen. It's the water in the ground that's frozen. All right, and you've got basically two kinds of permafrost. You've got permanent permafrost, that is, the ground is frozen. If you thaw it out, it will refreeze. You've also got what is called temporary or relic permafrost. That is permafrost left over from the last ice age. So, for example, when I talked about that ice sheet that covered 1/3 of North America, the ground became frozen underneath that as permafrost. But as the glacier has retreated, and in northern or central and northern Canada, now it's been gone for about 8,000 years, the permafrost line has been retreating all of that time. But there are still some areas, if your listeners want to go and look at a map of Manitoba, there's a town called Thompson, and this is a measure of how our geography minds are wrong. They talk about Thompson as being northern Manitoba. In fact, it's right in the center of Manitoba. There are building lots in the city of Thompson where the council rule that you cannot build on it unless you build it on your house on stilts, or you get steam heat in and thaw out the permafrost that's still there.
Why?
Okay. Well, because the soil is a very, very poor conductor of heat. And so it's if you put some ice out and cover it with dirt, a certain depth of dirt, that ice will remain frozen for a very long time. And so this ground that was frozen, during the last ice age is still not thawed out yet. But of course, as the world warms up, gradually the heat gets down into the ground and it thaws it out. Now, in the area of the permanent permafrost, every summer, the ground that's exposed, the upper layer of it will thaw out. That's called the active layer. And it can vary in depth. And it can be a problem, by the way, the permafrost. Just to give you a quick little story, when Franklin and his expedition they died up there. They spent hours and days trying to dig a grave to give a proper Christian burial, and they couldn't do it. And the town of Churchill, what they would do is in the summer, they would dig the graves they needed for the coming winter. They'd estimate how many people were going to die. And of course, then when the local the Eskimos or Inuits, as we call them, and the Dene people, the Aboriginal people, said, "Hey, you're tempting fate. That's not a good thing to do." And so what they do now is they've got a special device that they sit over the area where they want the grave, and they thaw out the ground with a lot of heat. And so they only thaw out the graves that they need. But once the person is put into that permafrost grave, they remain, they don't decay. They're frozen. And one of the situations I got involved with a Dr. Ewart was that there were people buried at York Factory on Hudson Bay in this permafrost, and in the cemetery at York Factory, 80% of them had died of smallpox. And what Dr. Ewart was afraid of was that the government were planning to clear the bush and the willow scrub, and that would have allowed the ground to thaw out. And he was afraid that this smallpox, which had supposedly been eradicated on a world basis, would become active and live again. As I said, the bodies are intact. And you can read about those, the Franklin expedition, the bodies that were exposed. What's his name? Owen Geiger, the author. I'm trying to think of his name. He wrote a book about it, Frozen in Time. about these bodies frozen permanently in the ice. And of course, they're marvelous for science to learn about. And it's from those bodies, by the way, they found that the Franklin expedition died of lead poisoning because they could test the lead flesh. But anyway, so that the active layer thaws out. That's, of course, one of the things that makes any development in the North problematic, because here you've got water, ground, earth that's thawed out, very, very saturated because it was frozen in the wintertime, and it's sitting on a layer of ice. And so you get this land moving or flowing, and it creates incredible landscapes and features. It's a process called solifluction. And of course, soli is soil and fluxion is flow. And you get these features of stones being sorted into geometric patterns and stripes down the sides of hillsides. And the early explorers thought that these were simply done by the local people. But in fact, they're part of the natural landscape of a permafrost region and this active layer that thaws out every summer.
I just saw the book, by the way. It's called Frozen in Time, The Fate of the Franklin Expedition, Owen Beatty and John Geiger.
Yeah, and I hate to mention that because I gave them all the what the weather was like for that period of time when Franklin was in that region. If you look in the book, you'll find me referenced in there. But anyway, and Dr. Ewart, by the way, the book that we did on the naturalists of Hudson Bay, 18th century naturalists of Hudson Bay, we dedicated our book to Dr. Ewart because sadly, before he could retire and work full-time at the medical records of the Hudson Bay Company archives, he passed away. But his work on the smallpox in those graves was very important work. But anyway, these permafrost then, what happens is that when it thaws out, of course, it's very saturated. It becomes swampland. Now they call it in the Arctic region, it's muskeg, and of course there's certain vegetation that grows in it. The major one is sphagnum moss. Sphagnum moss, of course, is very important for the people, the indigenous people of the area. It can hold 18 times its own weight in water. But of course, it fills in it gradually grows into swampy areas, and it looks like a solid surface. But the minute you step on it, you're going to disappear out of sight. And you go and read the stories of the American Army trying to build the Alaska Highway back in the war, and whole bulldozers just sinking out of sight into these muskeg swamp areas.
But here's my question about the thawing permafrost.
Well, as it thaws out, of course, the methane from it is released into the atmosphere. That's what they're arguing. And they're arguing that with global warming, this will increase. And since methane's a greenhouse gas, it's going to cause this problem.
Got it. So that's what that's about.
Yes.
But how come the permafrost thaws out? What could be making it thaw out?
Well, it's not thawing out. Remember I mentioned earlier about going up the side of the mountain or going up the side up in latitude?
Yes.
And you reach a point of the permanent snow line, and of course beyond that, the snow doesn't melt in the summertime, and the permafrost doesn't melt in the summertime. And so what they're arguing is that as the world warms up, that line of permanent snow line is retreating up the sides of the mountains, which of course then has effect on the glaciers, but it also has effect on the permafrost. And what I'm telling you is that the permafrost has been thawing out for the last 12, 15,000 years since the glaciers started to retreat. And so what's going on is perfectly natural. And by the way, Kim, one other thing, one of the reasons you haven't heard much about methane is because people like me and others were pointing out that the atmospheric level of methane, by their own measures, has decreased over the last 15 years, not increased. And there's another interesting part of this. When they started the methane story, and the permafrost was one of the early ones, and it's come back again, they started out by saying, oh, there was more termites. And there were more termites because of agriculture in Africa and clearing of the forest and so on. Then they discovered that the scientists had miscalculated by a factor of 4, so the termites were off the list. Then somebody said, well, it's because we're not trapping the beaver, and there's more beaver ponds and more muskeg and swamps, and therefore more methane being produced. And then that was shown to be false. And but one of the things that was never mentioned, they pointed the finger at the number of cattle, and there's no question cattle produce methane both ends. In fact, they produce more methane from chewing the cud than they do from the other end, and that's only one half of the formula. Because in the last 120 years in North America, we've gone from about 120,000 cows to about 86 million. So no question, cows produce methane, there's an increase. But on the other side of the formula that never got mentioned was we've regrettably gone from about 65 million bison down to about 120,000 bison. Now that is regrettable.
How did that happen?
That's a different issue.
How did that happen?
Well, it happened because of a couple of things. One is that the spread of agriculture, fencing in the land, but also the main thing was, of course, the providing of guns. And
you mean the bison was hunted down to that number?
Oh yeah.
Okay.
Yeah, and of course one of the things that people thought, well, the white men brought the gun, but actually most of the hunting for the white men was done by the native peoples. So, of course, they were, with the guns, they were just 10 times more efficient. It's the same as at Churchill. They shot geese every spring because the geese became their major food supply the following winter. They would salt them down in barrels. Well, the average Indian could shoot 5, 6, 7 times as many geese as the average European could. So they simply hired them to do the job for them.
What is your biggest concern about climate, even if it's cyclical? Is your concern the cooling? Talk a couple of minutes about that, and then I want to invite you back to talk about a few other subjects.
Yeah, well, the cooling, when you look at history, plants and animals, which of course includes humans, generally grow and proliferate and benefit from warmer temperatures. And when things get cold, you get all sorts of difficulties developing. Not only, and by the way, most of the major advances in human history are trying to deal with cold. I mean, the discovery of fire, for example, was creating a microclimate to let you live in areas you wouldn't normally be able to live. Clothing was another factor because the early people were living up close to the edge of the ice. I did a work with a Professor Mickeljohn, an anthropologist who was working in Europe, and he was trying to figure out how close to the ice these people were living, and they were living right at the ice front because that's where the great herds of animals were being pushed, and that was their food supply. And so the cooling, it is really, really devastating. It reduces the amount of available land for agriculture and quite significantly. It reduces the variety of crops that you can grow. For example, back in the 1970s, because the world was cooling down, the United Nations commissioned research into the impact of cooling, the coming cooling trend. And the CIA did, to my knowledge, at least 3 reports on the impact of cooling, how it would reduce food supply, cause social unrest, and that the governments better be ready for this. And so the biggest problem now is we're heading for that kind of cooling, but we're preparing for warming.
Isn't that frightening? That's what I said a year and a half ago when I first started learning all this. Most of the populations are preparing for the wrong cycle.
Right. And the thing is that you can't be in a win-win situation. You never can. I mean, every time there's change, there's winners and losers. It's just that you want to reduce the amount of loss as much as you can. But I've argued before the Canadian government and the American government when I was in Washington, if you prepare for cooling and it warms, that adaptation is much, much easier than to prepare for warming and then it cools. And if you look, say, for example, and we'll take Canada or the northern U.S., if Canada cools by 1.5 degrees Celsius on its annual average temperature, we're effectively out of agriculture.
That's frightening.
Right. And also, of course, the northern states of the U.S. I mean, you think about North Dakota and all through there. If you get them preparing for cooling and it warms, and nobody's farming north of Canada, right? But there are people farming south of Canada and the U.S. And so the adaptation is that much easier. And so it's a bit like Pascal's theory, isn't it? That they said, "Do you believe in God?" And he said, "Of course." And they said, "Well, you're a rationalist. You're not supposed to believe in God." And he said, "Well, I figure if I believe in God and there isn't one, I haven't lost anything. But if I don't, believe in God and there is one, I'm in a lot of trouble." All right. So it's logical that we should prepare for cooling because we can adapt to warming. I like to tease some of the extreme environmentalists. Say, look, we're preparing for warming and the cooling is coming on relatively quickly. That the only hope to produce the type of seeds that we need to adapt to that genetic modification is the only answer. Well, of course, they don't want to hear that answer either.
So are you saying you're for GMO seeds?
Not necessarily. What I'm saying is that plant breeding is a very crude form of genetic modification.
Got it.
It takes you about 15 years to get the kind of plant that you want with plant breeding, but with GMO you can do it in 18 months. And so it has dangers with it, but it's a much more rapid response.
I'm one of those people after my investigations into genetically modified food and the organizations that are involved in this, that file patents on the molecular structure of seeds, that file patents on animals, I can leave it. But I think getting hybrid seeds and being able to deal with cold environments, we have to be thinking about it.
It's not necessarily the technique, it's the people that use and misuse it.
Yeah. Unfortunately, I think when people start splicing DNA and altering genetics, I think that what ends up happening is they start to think they're God and start to do things that cross the line of appropriateness. And the thing is that a lot of these organizations are never going to be able to be monitored.
No, and of course that's another part of the thing you and I have been discussing all along, because science, in effect, through Darwin, got rid of God, which then, of course, they replace him. They are now the gods, and the religion is environmentalism, because the young people need a moral belief, and environmentalism provides them with that. So, that's part of this whole debate.
I really appreciate you being our guest. Ladies and gentlemen, we have been talking with, listening to, and learning from Dr. Tim Ball. He's a climatologist. He has been teaching for 40 years. He has thousands of articles, and very soon you'll be able to go to his new website, drtimball.com. Thank you so much.
Thank you.